If your app depends 100% on the internet, then your app is fragile. Senior developers design apps that work even when the network is bad. That's why we need database and caching strategies. Let's talk first, what does caching mean? Caching means save data somewhere locally so you don't need to download it again every time. For examples, product list in e-commerce, transactions in fintech app, notes in a notes app, user profile data. Why we need a database in mobile applications? Because network is slow sometimes, network can disappear completely, and APIs can fail. Users expect fast applications. Database gives you speed, offline support, better user experience, and lower network cost. Room in Android. Room is basically SQLite but friendly. Instead of writing raw SQL everywhere, Room gives you entities, which means tables in your database, and DAO, data access object, the queries, and database clause. Room is perfect for structured data, relational data, and long-term storage. What is the difference between SQL vs NoSQL? SQL relational. Think of it tables plus rows plus relations. Best for transactions, banking, orders, anything consistent. For example, user, orders, and order items. NoSQL document based. Think of it like JSON documents, best for flexible data, changing schemas, and chat messages sometimes. Analytics events. For example, Firebase Firestore. In Android, what should you use? Most real applications use Room SQL. Why? Because it's stable, fast, safe, and works offline perfectly. NoSQL is used when backend is already NoSQL. You need real-time sync easily, Firestore. Caching layers. A professional app usually has multiple layers, like memory cache, exists while app is open for UI speed, for example, cached objects in view model, and disk cache, database, Room or SQLite, survives app restart, offline support, and network, source of truth sometimes. Slowest layer, offline sync. Offline sync means what? Means user can use the application offline, and when the internet comes back, everything syncs correctly. For example, user creates note offline, and later network returns, then app uploads the note automatically. Common offline sync strategies. Strategy 1, network first. Try API first. If fails, use a local cache. It is good for data must be fresh. News app. And strategy 2, cache first. Show cache data instantly. Update in background. It is good for e-commerce product list, social feeds. And strategy number 3, single source of truth. Best practice. Room is the main source. API only updates Room, and UI always reads from Room. The result, consistent state, clean architecture, easy testing. For example, when a screen opens, UI requests data. Repository loads from Room immediately, and repository calls API in the background. API updates Room. UI updates automatically via flow. The biggest mistake, which is very common, saving everything in shared preference, mixing API plus database logic in the view model, and no clear caching rules, no conflict handling for offline updates. Database and caching are not extra features, they are core system design. If you design caching correctly, you have a faster app, works offline, smooth sync, and clean architecture. Thanks for watching and see you next video.